this is Alex Kuza, and welcome in Artificial Intelligence and Product Strategy podcast. Let's talk about today about artificial intelligence for the metaverse in the application aspect. And those of you who remember last episodes when I was talking about how artificial intelligence contributes to metaverse development and what are the ways to make a profit in metaverse with artificial intelligence, those of you also remember that I was talking about specific areas where Metaverse is already monetizing artificial intelligence leverage. Today, I would like to talk about four of those areas. Those are healthcare, manufacturing, smart cities, and gaming, but also give you a clear and precise artificial intelligence techniques that you can pursue to build profits, positive return of investment in metaverse world. So let's talk about the first area today, first application aspect, which is healthcare. Regarding healthcare, we can talk about several different applications of AI techniques that are precisely developed or structured to help to deliver the specific results. First one is inertial sensory-based physical activity recognition for healthcare and wellness. This is super important, for example, in physiotherapy, when you need to use your body as a pattern movement, and then artificial intelligence can actually check if that pattern is the one that doctors or specialists expect. In this particular case, CNN with encoding algorithm to convert inertial sensory signals to color images are very useful. Those can translate the signal to imaging and give you a perspective of how that specific movement was done, delivered, and what is a pattern alignment with that. The second thing is physical activity recognition to support physicians and health wellness experts in making decisions in living assistance and healthy risk awareness, especially important in elderly assisted living spaces and places, or other spaces like hospitals, when we need to assist those that are requiring assistance, and also we want to make sure that that assistance is delivered properly. Here, residual CNN to extract deep features is very important in combination with handcrafted features based on the intermediate fusion mechanism. Those techniques can help a lot to find patterns, categorize patterns, and make a decision or augment the decision process in building that specific recognition. The third area in healthcare is wearable devices based fail detection for Internet of Things based healthcare and medical services. Here we have hierarchical deep learning framework with CNNs for learning models at local devices and global cloud center. We can conduct the metrics and conduct the calculations on the device or in the cloud. In both cases, hierarchical deep learning and CNN can be very helpful, and the fall detection is pretty straightforward, how it helps in our daily life to maintain health and wellness. Another thing I would like to tell you about is segmentation in breast ultrasound images for detecting abnormalities. Um, breast data analysis is super efficient when we can use silency guided morphology aware unit or SIM-UNET involving an additional middle feature learning stream and network. This can be very helpful in analyzing that particular area of our body and being more precise that particular sensors and the signals coming from that sensors. So that was healthcare, several descriptions of how we can leverage and what specific AI techniques. Let me move now to manufacturing. In manufacturing, we have at least four different areas. Automatic production system reconfiguration and upgrade to shorten product life cycles and increase the number of product variants. For instance, if we want to produce a new variant, new flavor of something, or we want to produce a new hair shampoo with a new structure and ingredients, symbioting with reinforcement learning strategy can be very helpful, especially when we combining the learning capacity of Q-learning models and the domain knowledge of experts. Combining those two, we can quickly show up several different product variants and also help to shorten product life cycles, which can be important, for instance, in the beauty industry or in healthcare industry as well. The next area is reliable fault detection and diagnosis for quality inspection of production line and manufacturing. Everybody wants to predict when something happens, especially if it's a failure. So here we have three techniques we can use. First one is deep encoder decoder framework using RNN architectures with attention mechanism. Second is data-driven learning model using deep networks with LSTM architecture. And the third one is data-driven learning model using transfer learning mechanism on CNN architecture. As we can see, CNN is pretty popular in different cases here. It's mostly because neural networks are pretty universal, but at the same time, it's mostly unsupervised learning, which takes a lot of time and more resources than supervised one. But anyway, when it comes to fault detection and diagnosis, we can really use those three techniques to build those value right there. The fourth area in manufacturing is forecasting. And forecasting can be done by a combination of regular artificial network and a generic algorithm. Those are pretty generic techniques that can be widely used, and there is not rocket science to start with them. But in case you are deciding how you want to approach forecasting or how you want to maximize productivity of the production line, you can start right there. Maybe this is something you haven't realized yet, and that could be also helpful. And the last area in manufacturing is production progress prediction to optimize on-time order delivery activities, especially to make to-order manufacture enterprises. So if you can imagine automotive industry, or you can imagine a marine industry, when you really need to manufacture something from A to Z with many vendors, this area can help you to progress prediction to optimize on-time delivery. I'm not talking about just in time, because recently after COVID, those supply chains are too broken to talk about just in time, but you can optimize the delivery time. Very popular in BMW, especially when they were when they working on digital twins factories. I was talking about digital twins in one of the previous podcasts and previous YouTube podcast as well. So in this case, we can use data-driven learning model using two-stage transfer learning mechanism on a deep belief network architecture. That technique is one of the best and one of the most efficient in production progress and prediction to optimize on-time delivery. Let me now move to smart cities. Smart cities are something that we will see more in the future, cities that can predict what we want and when we want. And first area is smart home appliances control and management. Imagine that this coffee maker or this stove actually understand the patterns, and instead of you pressing the button, the stove start the process by itself, asking you for baking that bread. In this case, a set of AI algorithms for brain signal processing and decision making to respond simulation commands. It's very, very useful. Another case is intelligent IoT-enabled urban traffic control and management system. We're talking about buses or trams coming to you not according a schedule, but dynamically decided where to go. For instance, depends on how much is the traffic. Those intelligence systems are now in progress, especially in Saudi Arabia and those countries that are constructing that smart cities from scratch. Here, hierarchical AI framework by deploying machine learning algorithms in a digital world to automatically make decisions in the physical world is super important. So for instance, you have a coffee maker, machine learning powered, This maker, for instance, learn patterns on daily basis, and then it stimulates the physical world. So that's how it can be tackled. Another area in smart cities is early air pollution warning and management in smart environment surveillance systems. Those are usually deep learning frameworks with IDCNN coupled with bi-directional LSTM networks. And the last one is smart cities is sustainable agriculture from smart farm to intelligent food production line. Smart farms are very interesting cases. One of the big use case in smart farm is personalization. We might say more like plantinization. What I mean by that, if you can imagine a room full of people listening to the lecture and one of that person has a flu, that specific person take the medicine while the rest of the people don't take that medicine. It's not essential. In agriculture, when the one plant is sick, the farmers they usually treat the whole farmland or the part of the home or of the farmland, also treating the healthy plants, which is now a waste of resources, but also influencing the health plants in the wrong way. So digital farming is going to a direction when there will be a personalization, we might say. In this case, AI framework for supervised learning with conventional machine learning algorithms applied in detection, classification, and recognitions models are super efficient. So if you want to bring more personalization, but also more intelligent farming, deciding according to a weather or what was planted in a specific field before, if you want to tackle those issues, the AI frameworks with supervised algorithms are super important here, especially that you can get a lot of raw data from satellites, weather, and other API systems. And let me now move to the last area, which is gaming. In gaming, we have a lot of different use cases when artificial intelligence can support metaverse effort, but I want to tell you about two of them. First one is modeling multi-scale uncertainty and multi-level abstraction levers in RTS games. Here we can use multi-scale Bayesian models, including Bayesian networks, and maps with probabilistic learning for multi-level units control. The second area in gaming is design of a testing mechanism for game flow evaluation in artificial chess games, for instance. We can use a lot of machine learning frameworks here. Also, development of AI agents or development and AI engines and improvement of tactical intelligence. Here we can use RNN, CNN, reinforcement learning is super useful, but also Q-learning networks. I hope you find this section very interesting. The goal of that was to give you a specific algorithm, AI technique that you can use for tackling the specific problems in those four areas. Metaverse benefits a lot when the artificial intelligence solve specific problems because we know that narrow AI can now bring the most valuable solutions to the table. Thank you so much for being here and see you in the next episode.